Hi, Integrated Math 1. Welcome to our Unit 3.1 review on Introduction to Exponential Functions. Yay! So we're going to kind of kick it off. I will warn you, number one was probably the most labor-intensive problem. It wasn't hard, but I had to do the most work for it, probably more than any of the other problems. It wasn't terribly hard though. So let's go ahead and kick this off. So we're given this geometric sequence, g sub n equals 8 times 4 to the n minus 1 power. And what we want to do is we're going to start by writing our geometric sequence as an exponential function. Now remember, exponential functions look like a times b to the x power. And the b is pretty easy, right? Because the b is just our constant ratio, right? That's really easy to find, no big deal, we can handle that. The trick was finding that a value. Now, if you remember the a value, that was your first term divided by the constant ratio. So for this situation, in order to find my a value, my y-intercept, because maybe I should write that as well. That's the y-intercept. To find our y-intercept, we needed to do our first term, which in this case is 8, and divide it by our constant ratio, which in this case is 4. And of course, 8 divided by 4 is 2. That also means my b value is just that constant ratio. So my b value is 4. Great. Now it's easy to write the function. So f of x equals 2 times 4 to the x power. There you have it. Now, part B says to graph the function for all integers n such that 1 is less than or equal to n is less than or equal to 10. That looks complicated. All it's asking you to do is graph the function. And they're suggesting that you use the numbers 1 to 10 to plug in and sort it out. Now, what I'm going to do is I'm going to keep in mind that it was n minus 1 to get x, right? Do you notice that? The x is n minus 1. So what I'm going to do is I'm going to make a table. And instead of starting at 1, and so that's going to be my x, that's going to be my f of x. Instead of starting at 1, it says n minus 1, so that's going to be 0. And then I'll just count 1, 2, 3, 4. And you can go as far as you like. It says to go all the way up to 10, so I guess we could go all the way up to 10. I'm going to go this far, and we'll take it from there. I should warn you, on the solutions PDF, that's part of Google Classroom here, you'll find on that one, I went all the way to 10. And you're welcome to do that if you like. I think I'm just going to stick with 5, and we're going to do the graph a little bit differently. And that's okay as long as we label things correctly. So if I plug in a 0, of course, that's 2 times 4 to the 0 power. 4 to the 0 power is 1 times 2, which is 2. But I guess we knew that because that's our x-intercept, our y-intercept. And actually, while I could plug in, we also know the pattern is to multiply by 4. So yes, I could plug in, or I could just grab a calculator and I can multiply by 4. So 2 times 4 is 8, times 4 is 32, times 4, oh, hang on, times 4 is 128, times 4 is 512, times 4 is 2048. Now, again, this does ask you to go all the way up to 10. So you want to keep the table going and go all the way up to 10, that's fine. It's just going to change your graph a little bit. And again, you can look at the graph on the PDF that's with this assignment in Google Classroom, and you can see what I did there. But I'm just going to go up to 5 for now. So I'm going to be like, that's 1, 2, 3, 4, 5. I do want to label. That's my x-axis, right? So I'm going to be like, my x-axis. I'm going to make my y-axis or my f of x. I'm going to go, woo. Oh, it's much easier on paper where I can use a ruler to make sure I write it straight. Now, I noticed that my biggest number is 2048. So I want to make sure I can get all the way up. I'm going to say that's 2,000. I want to make sure I can get all the way up to 2,000. So what if I count by, I don't know, so many choices. Actually, I'm going to make this top guy 2,000 just to make it easiest. I'm going to make this very top line 2,000. So since it looks like I have 10 spaces here, that means each of these spaces will be 200. So since this is going to be 2,000, half of that, will, of course, will be 1,000. And of course, you can take it from there, right? This is going to be 200. This would be what? This one would be like 200. So that'd be, so 100, pardon me. Oh my gosh, Miss Scott, what are you doing? Having issues. So that'd be 200. So that'd be 400, 600, 800. And you don't have to write every single one in. In fact, I'm going to erase that 1,000. I don't need that there. So that would be 1,200, 1,400. That'd be 1,600. Just so I have an idea. Like I said, I put 2,000 at the top. I want to make sure I could get there because of this number down below. So let's go 0, 2. So 0, if this is 200, 2 is going to be really low on my graph. 1, 8, again, that's going to be really low on my graph. 232 means I finally get a sort of move, but not much movement. Oh, sorry, I didn't get far enough over. I will fix. So 232. 3,128 means I actually get a touch over halfway finally. Yay. 4, 515. So 200, 300, 400, 500. 12 is just like a little bit above that. And then we said 5 was all the way at 2,048. So there's 2,048 would be just like barely above that, right? Like just the tiniest bit above it. Sweet. And so now you can make your nice little curve. Ooh, I can do it. I can do it. Whoa, arrow on the end, arrow on the end. There's my curve. It's not the best exponential curve I've ever made, but not the worst either. So like I said, this one was probably the most work intensive. And again, you could have made your table bigger. That means you would have had to expand your y-axis a little bit, and that's okay. So, number 2. Given the exponential function f of x equals -4 times 1/4 to the x power, I'd like you to complete the table and graph the function. Okay, let's plug these things in. So if I plug in a -2, that gives me -4 times 1/4 to the -2 power, which means I actually have -4 times 4 squared. 4 squared is, of course, oh, I need to do this. 4 squared is 16 times the -4 gives me a -64. Now, getting that first number is usually the issue. And in fact, you know what? Can I show you an easier way of doing this? I'm going to show you an easier way. Oh my gosh, why am I making this hard? I'll show you the easy way. You know what your y-intercept is. It's -4. You know the pattern is to divide by 4, right? If it's 1/4, my pattern is to divide by 4. So 1/4 of -4 is -1. 1/4 of -4 is -1/4. And now I don't have to do all the math. If we go backwards, though, that means I'm multiplying by 4. So if I go backwards, -4 times 4 is -16. Times 4 is -64. So yes, I could have plugged in. But we know how these work. We know that's the y-intercept. We know that is the pattern. So I'm just going to use it, right? Right. And now I shall plot my points. Now, obviously, not all of these points are going to fit on here, and that's okay. We're going to fit on here what we can. So -64 is way too far down there. That's not going to fit. That's all right. I'm going to work with the ones I can make work. So -1, -16. Please notice we're counting by 2's on this graph. So -1 is only this far. And of course, -16 is all the way down here. So make my little dot. Ooh, you can do it. 0, -4. So there's 0, there's -4. Sweet. Wow, that swept up really quick. 1, -1. Again, we're counting by 2, so only halfway. There's our 1, -1. And if we go all the way over to 2, we end up at -1/4, which is really small. Wow. Look at that. Look at how it's like fast, slower, slowing it down. Yeah. Oh, sorry, I'm having issues there. Not perfect? But you get the idea. And the best part is because we know that's the y-intercept, that gives me the first point for my table. And then I can just use that pattern to go, go, go. So let's keep this going a little bit. Let's actually use the things we were just talking about. I know it's listed as A and B, and I'm sorry, it should be B and C on your paper. My bad, I'll fix it. Identify the constant ratio and the y-intercept. Well, the constant ratio, that's pretty easy. So I'm going to say the constant ratio, and I'm just going to say it is 1/4, right? That's the base of our power. Awesome. And the y-intercept, well, that's just the guy in front, right? Is -4. It's this guy up here, right? Because remember the deal. It's our y-intercept times our constant ratio raised to the x power every time. Ooh, identify the horizontal asymptote. If you need to, you can go back to the graph and look at what we did. Take a look. It's getting closer and closer and closer to 0. It's getting closer and closer to 0. Yeah, and you can even see that on my graph that I'm getting closer and on my table. I'm getting closer and closer to 0. My output is getting closer and closer to 0. So please remember, since it's an output, we say the horizontal asymptote is y equals 0. Watch out for that. Yay! All right, 3 and 4, we've got some transformations going on. So let's look at number 3. Right away, I can see that my y-intercept is going to be a 1, because you could put a 1 out in front of that. I can see my constant ratio is 1/2. Yay. But we're going to do jump to it. So we're going to do g of x equals f of x minus 4. Oh my gosh, that's the d value, isn't it? So before I even do anything, I already know that means we're going to move down 4 units. Now, there are a lot of ways of doing this. I'm going to make a little mini table, and you can put as many points or as few points as you want on this table. I'm going to say that's x, that's f of x. I'm going to use the original, and then I'm going to move it down 4 units. I always like to do at least -1, 0, and 1. You can do more if you like. Like, I think I might throw a 2 on there. I don't know. But you can do as many as you like. You don't have to put the 2 on there. Never mind, I don't want you. So if I plug in a -1, actually, let's keep it simple. 0. That's the y-intercept. We said you can tuck a 1 in there. The y-intercept is 1. And that means the pattern is to cut it in half. Well, half of 1 is 1/2. That means if I go backwards, I'm multiplying by 2. 1 times 2 is 2. And now I have a couple points to plot. Now, watch what happens here. So I'm going to plot my points. We said -1, 2 is a point. Ooh. We said 0, 1 is also a point. And we said 1 and 1/2 is also a point. So you can see the curve that's happening here. You can totally see the curve that's going on. In fact, we could go back further. If you plugged in a -2 and you kept the pattern going, times 2 would be 4, right? -2, 4. So you can see what the pattern's doing here. That's pretty good. But I don't want this function. I want this function. So let me grab another color. And this means we're going to move down 4 units. So I'm not even going to draw the graph yet. I'm just going to take every single one of these points and I'm going to move it down 4 units. So this guy, 1, 2, 3, 4 units down. This guy, 1, 2, 3, 4 units down. This guy, 1, 2, 3, 4 units down. And my little halvesy guy, 1, 2, 3, 4 units down. And now we'll see how well I can do this. Now I'm going to draw my curve. And again, it's flattening out. We know it does that flattening out thing. And then it goes like up forever and ever that way. And it gets like crazy steep. It's not perfect, but you get the idea. We're also asked to write the equation for the transform function. So right now, I see that g of x equals f of x minus 4. But we were just saying that f of x equals 1/2 to the x power. So I can just take this and plug it in for f of x. So g of x equals 1/2 to the x power minus 4. Yay. So this is just a nice little shortcut for graphing these things. It's not perfect, but I mean, it works pretty good. We just shoved it down 4 units. Good job, us. So hopefully that gives you some ideas on what to do for number 4 as well. So number 4, we're asked to graph the transformation. I can see the little +2 here, which I will worry about in just a little bit. Let's start with the original function and then take it from there, shall we? So if I were to plot points for the original function, x and f of x, and we like to do at least -1, 0, and 1. You can pick more points if you like, but I'm going to start with these. You're always welcome to pick more points if you're trying to get a better visual on what's going on. And of course, this is pretty easy because we know that the y-intercept, you could put a 1 in front of that for your y-intercept. It's up to you. Or just plug in a 0. 4 to the 0 power is, of course, 1. We can see the pattern is to multiply by 4, so 1 times 4 is 4. That means if we go backwards, we'd be dividing by 4. So 1 divided by 4 is 1/4. And I can plot these points and I can be like 0, 1, and then it can be like -1, and it only goes up to 4th. Wow, I didn't even make it up halfway. And then 1 all the way up to 4. And again, if you wanted to plug in another point, if you want to plug in a 2, 4 to the 2nd power is 16. I guess I'm not going to plug in a 2 because that doesn't even fit anymore. Now, this is not the function I want, right? These are not the functions you were looking for. This is not the function I want. I want this function, right? G of x. So here's what I'm going to do. This little +2, do you remember the minus c trick? Yeah, that means that c equals a -2. This is my c value. My c value is -2. And so because the formula is x minus c, I have to do the opposite, right? I got to work backwards here. So that means I'm going to move left 2 units. So I'm going to take all of 3 of these points that we just made, and I'm just going to go left 3 units. And that's all I'm going to do. So I'm going to take this point and go 1, or not 3 units, 2 units. You know what I mean. So I'm going to take this guy and I'm going to go 1, 2 to the left. And I'm going to take this guy and I'm going to go 1, 2 to the left. And this guy and 1, 2 to the left. And now I can connect my points. Make my lovely, I can't quite reach 16. It's too high. And it's going to flatten out. Ooh, flatten out over here. Reaching for that 0 that it never actually gets to. Boo, so sad. Oh, of course, we do need to write the actual equation for it. Okay, so it says g of x equals f of x plus 2. And we were told that f of x is 4 to the x. So this just means instead of an x, I'm replacing it with x plus 2. So instead of 4 to the x power, this is going to be 4 to the x plus 2 power. There's my function. Yay. That's not so bad. Well, you survived the worst of it. 5, 6, 7, and 8, these are pretty easy. So let's take a look at these. And always read the directions carefully. That's what I would recommend. This is to write the expression as a single power. Well, I can see here that I have the same base. So I'm going to keep that base of 10. And you know that if you're dividing these guys with the same base, that you subtract the exponents. So 7 minus 10 is a -3. Now, it did just say to write it as a single power. It didn't say anything about simplifying or making it pretty. So you are welcome to leave it this way if you like. Totally fine. If it bothers you, I guess you can play with it further, but I'm just following directions. Write it as a single power. There it is. 1 power. Good job. This is asking us to rewrite the expression using a rational exponent. You could even think of it as a fractional exponent. Maybe that'd be an easier way of thinking of it. Yes, yes. You remember the deal that if I have something to the and I'm going to say the m over n power, remember that this guy is your power and this guy on the bottom is your root. Do you remember that? The top guy is the power, the bottom guy is the root. So I'm going to keep my base of 3. I still have a base of 3. It looks like I have a power of 7, so that's going to be the numerator of my exponent. And I have a root of 6, so that will be the denominator of my exponent. And we are done. It didn't ask us to solve it. It didn't ask us to work it out. It just said, write a rational exponent. So I did. No problem. Number 7, solve each exponential equation for x. Well, this was the deal where I was trying to get them to have the same base, right? So I want them both sides to be powers. I just want them to both to be powers with a base of 3, since he already has a 3. So that's already 3 to the x power. I'm cool with this side. This side needs some love. I need to write it as a power with a base of 3. So I'm going to do some multiplication here. 3 times 3 is 9. Times 3 is 27. Still not big enough. Times 3 is 81. Golly, still not big enough. I better multiply another 3. Oh, thank you, Mr. Calculator. That gives me 243. So it looks like I need to multiply together 5 3s in order to get to 243. So that means I actually have 3 to the 5th power. Now that my powers match, my bases match, that means if my bases match, my exponent should match 2. And I can just drop off those bases and say, fine, x equals 5. Hooray, hooray. Last but not least, real similar to number 6, very similar to number 6, very similar to number 6. Write the expression using a rational exponent. Again, this is our whole, let's write our exponent as a fraction. Right? The whole, going to write my exponent as a fraction. The numerator is going to be my power. The denominator is going to be my root, right? That's how this works. So I can totally rewrite this as p to the, I have a power of 9, so p to the 9 over my root, which is 5. So I have p to the 9/5 power. And there you go. Hope you found this useful. Hope you found this helpful, guys. If you have questions or concerns, come talk to me. I'm around, and I'll see you guys soon. Bye.